Hello everyone. Today we're gonna be going over this example about volumes of rotation of revolution. Sometimes it's called. So we're just gonna be doing this first example, and it just says find the volume of the solid constructed by rotating y is equals to the square root of x cubed about the x-axis between x is equals to 0 and x is equals to 3. Okay, so before we start with anything, it's important to remind ourselves of the formula that we uncovered in our last video for finding volumes when rotated for lines, 2D lines rotated about an axis. So specifically for rotations around an x-axis, the volume is simply just pi, the integral of y squared as a function of x dx from a to b. Okay, so I hope you remember that. And next step is we're gonna take it step by step. So the next stage, the first thing we're gonna do is we want to draw this function to get an idea of what it looks like, so we know what type of integration we'll have to do. So I'm just gonna be quick with this one. If you do get confused and try finding out how I drew this, it's a very simple function. It's not too crazy. So notice that this can essentially be written as y is equals to x is equals to x or to the power of 3 over 2. Like that. It basically means the same thing. So our x is still very much positive and greater than our exponent is still positive and greater than 1, and well, greater than 1, so it tells us that it will be an increasing function. So it will look something like this. I'm just going to use a blue pen there, and so at x is equals to 0, y is also equals to 0, so it's going to start at the origin and it should just rise steadily like that. That's our x-axis, that's our y-axis. So we have to construct a solid between x equals to 0 and x equals to 3. So I'm just going to plainly put x is equals to 3 there, so that matches with that. So that's going to be our 3, and that's obviously our 0. It should start at 0, sorry about that. Okay, so the next step is we want to feature our formula there. So we're just going to write this plainly. I'm going to use black. And we're going to have our volume is equals to pi and the integral of y squared. So I'm just going to put y inside brackets, and our y is x to the power of 3 over 2, okay, and squared dx, and our a is 0, and our b is going to be 3. Oh, is it the other way around? Sorry about that. From 0 to 3. Sorry about that. Okay, and next step is we're gonna have to simplify this before we can start integrating. So we're gonna just work on that bracket that's inside our integral. We're gonna keep this integral here, and we're gonna have x is equals to 3 and x to the power of 3, because that 2 and that 2 will cancel, and then we're going to be left with dx. And this should be very simple if you've been doing a lot of calculus of late or have any experience with it. So it should be something like this. We're just going to keep that in brackets. The integral of x cubed, okay, that should be x to the power of 4 all over 4, and from 0 to 3. That should be fair enough to remember. Okay, and we're just gonna expand on this bracket. So we're gonna get that's gonna be 3 to the power of 4 all over 4 minus 0 to the power of 4 all over 4. Okay, and 3 to the power of 4, I suspect will be, sorry, hold on, I should have calculated this. 3 to the power of 4, and that's just 81 divided by 4, and it's still just 81 over 4. So our answer here for volume is just 81 pi divided by 4. Simple as that.